time? Yeah. Good afternoon. Okay. Good afternoon, everybody. Welcome to RIFT session IETF115, and we are about to start. So the session is being recorded. Dr. Pshenda, please wear your mask. And if you haven't read Not Well, please do so. And the IETF policies that are in effect, and you agree by participating to adhere to the policies as put in all the documents you can read. So the BCPs and privacy policy. Next slide, please. So please wear the mask, please be courteous, and please scan the QR code so you would join the meeting. We don't do blue sheets anymore. So the quick update, we are going to have a presentation from Jordan on basespec update and KV registry, then out of fluid reflection that we plan to adopt after this meeting, and then Sandy will talk about leaf-ring. So what's going on in working group? Pending Alvarez reviews, base specification, applicability statement, Young model. There's been some progress recently. We need to finalize Shepard write-up for KV registry. The auto EVP and flood reduction is still in progress, actively working on it. We've got a new individual draft on leaf rings, and Rift SR and multicast is still on kind of side border. We do plan to work on it after we update the chapter. Yeah, so Jordan, join us remotely, I assume.
Can you guys hear me okay?
Yeah, we can hear you.
Awesome, okay. Okay, hey everyone, my name is Jordan Head. Just going to provide an update on how the Rift base spec is progressing, as well as several others following this. Next slide, please. So version 16 of the draft was pushed a couple of weeks after IETF 114, following the most recent round of AD review. Some of what I mentioned here, it was mentioned there, but some of it bears repeating. So overall, the document continuing to improve. I won't mention every detail, but here's kind of a rough outline of what we've been working on. So as the documents evolve, a couple of concepts need to be clarified in text. Just as an example, how ties are serialized on the wire. A couple of other readability components like adding pointers to the Reader's Digest for like some security concepts. Beyond that, SVGs and ASCII art now align properly, and what I mean by that is they basically tell the same story and provide the same value regardless of the format of the draft that you're reading, kind of as was intended. It's kind of worth noting we got some pretty good feedback from external readers as well, so it's good to know that those are actually helping. Other SVG optimizations kind of helped us get around a lot of the IETF tooling challenges. There's a fair bit of work that went into them. I think they provide a lot of value, especially for the more complex topologies. But it's worth noting that it's pretty difficult to actually get them to work within the confines of the existing IETF tools. So it's something I'm following up with some of the tooling folks and a couple other avenues. I digress. Updates to the IANA consideration section. We had to actually push the new version of the thrift schema, as well as a couple of little phrasing fixes for what IANA had mentioned to us. Next slide, please. And then the usual kind of editorial changes, grammar, spelling, flow, references, etc. And then last but not least, some improved kind of inclusion, diversity, sort language. Next slide. And as for what's next, we're continuing to work with Alvaro and AD, and we'll keep applying as soon as we can, and kind of keep everything moving forward. I also owe Alvaro and the chairs and the Shepherd a brief thread to kind of rework the Shepherd review so we can get myself named or officially tied in as a co-author. But no, that's it. Next slide. Comments, questions, concerns. Okay, jump to the next one.
Is Sasha on the queue for comments? Sasha, do you have anything?
Sasha, you're on queue.
Okay, brief update on the KV registry. Next slide, please. I think Jeffrey covered a lot of this, but essentially we've got there's nothing terribly exciting in new versions. It's mostly edits due to Shepherd review, things like, references, boilerplate, etc. Next slide. And kind of beyond, just waiting for the write-up, IANA actually reached out a couple of days ago and pointed out that we need to specify a couple of ambiguous things, basically to specify upper bounds for some of the values and things like that. So we'll get that adjusted, along with Shepherd feedback in the next version. Next slide. And that's it. Questions? Okay. Okay, last but not least for me. So flood reflection got some updates as well this time. Next slide, please. Okay, basically we've added a role for spine nodes, which is just a way of saying a way to specify spines as a specific entity, or non-flood reflector client or non-flood reflector nodes participating in AutoFR. So this lets us, advertise some kind of generic state about the spine that might be important to the overall picture of the flood reflection topology. And beyond that, it kind of lays the groundwork, or adds the capability for any spine-specific variable derivation should it be needed in the future. We added a bit more to the telemetry key value ties. So basically, we can now carry and describe state for the kind of the regular or internal level 1 ISIS adjacency within the fabric. Next slide. Slightly more detailed view. So basically, the items in bold are what's new. So kind of as an example, if we were advertising KVs from a flood reflector client, a leaf node, at the top of the fabric, we'd be able to see the state of, functional versus total level 2 flood reflector adjacencies to the actual flood reflectors themselves. Functional versus total level 1 shortcuts between leaf nodes for any deployments that leverage them, and then as I mentioned, the new one, functional versus total level 1, air quotes, regular ISIS adjacencies that describe more of the underlying ISIS topology. So the operator really benefits in that they can see the entire fabric from the leaf and spines point of view, but all from a single TOF node. Next slide. Some more SVG stuff for this one. So the operational section had an SVG that sort of described how the Rift underlay, the base ISIS topology, and then the flood reflection topology all fit together, depending on location in the fabric. Previously, we only had it working in the PDF version, but kind of similar to the base spec, got things compliant with the draft upload tool and things like that. So now it's in the HTML version. So I think it keeps things kind of nice and crisp. Next slide. So Jeffrey mentioned this too. I know adoption's waiting on the rechartering discussion. So, hoping to see things progress on that front. As for future updates, right now there's more KV stuff slated for the next version, and then we're still kind of noodling around with the multi-plane flood reflection stuff. And that's it for now. That's it for me. Any questions about AutoFR?
I
Okay,
actually have
easy.
one question.
Sure.
So was this presented in the LSR at all? Because my understanding is that this will be used for ISS flood reduction, right? So what does SR think of this?
The questions that kind of came up there, it was presented. I forget which meeting. It was a couple meetings ago. Basically, their only question or concern was, does it overlap with any of the other working groups, like the auto configuration stuff for IDR, et cetera? And it doesn't, right? We're not actually modifying. This doesn't actually modify ISIS. We're just using Rift to kind of leverage some of the, we're leveraging Rift's distributed nature to basically build the configurations and, determine what things are where. So no actual conflict for us.
So if ISIS implementation wants to make use of this, do they need any specification in LSR or not? Or do they need interop between other routers? Things like that.
So there is an LSR spec for flood reflection itself. This is just the auto configuration portion. So it depends how you want to do it. If they don't need the auto configuration pieces of it, then they don't need it. If they do and they want to run Rift, then yeah, they follow this spec and along with the LSR one, and you get both. Looks like Tony wants to add something.
Tony P. Juniper. Man. So we do not need any LSR specs. If you have this thing implemented with ISIS, then the only interaction surface is really pulling out the analytics, right? Which is always very vendor specific. So the ISIS has to expose what it already does in some form or fashion, right? Worst case, you do CLI scraping. If you want to provide the analytics, you need the information out of ISIS. But the analytics is completely optional. So no, there is no implications in terms of scaling or implementation or specification we need to extend here. So far nobody came up with any ideas that this thing would do something stunning on ISIS that we have to add. So no.
Is this applicable to OSPF at all?
Tony P again. Yeah, well, so this idea is hanging for a while, and it's a very short road to fame and riches if you write flood reflection for OSPF, which is pretty much a straight knockoff of a high ISIS stuff. But there's just simply not enough customer demand. The OSPF networks are not big enough, and people are not used to that way, so it will be effort wasted. Yeah. You could add flavors to this stuff, for example, where you configure the flood reflection being L2, ISIS, and underneath have OSPF as L1, which would work just as fine, but there's no customer demand for it for the moment.
And probably after we recharter and decide whether we proceed with this work as a courtesy, we will share it with the LSR and ask for the reactions.
Yeah, and for what it's worth, I have we'll say, more detailed presentation that kind of addresses some of that stuff if that needs to happen with LSR again. So no problem.
So probably we'll target in a San Francisco timeframe and maybe present an LSR.
Yeah, okay.
Okay, so Jordan, you are going to provide a quick update on auto UVPN as well, right? No slides, but quick update, I think.
There wasn't any actual draft update this go around. There is some stuff slated for the next one. It's Auto FR happened to just kind of take priority. There's still some multi-plane and data center interconnect gateway stuff that we're working, as well as as the theme continues, the SVGs and making the operational section a little bit cleaner. So that's for next time.
Tony P again, to fill in a little bit more details. So basically, as far as I remember, the schema version encoding 6 added something where we know that we needed in case of multi-plane fabric to run a proper auto EVP and auto FR election. So we can actually distribute the FRs or the RRs across multiple planes, simply for resiliency reasons. But the election in itself has not been modified yet, the algorithm to take that into account. That's pretty much the thing outstanding. There is a little bit of work. So the schema, everything is here encoding. It's just, I need to add this little bit to the algorithm. We talk it through, we know how it would work, but it's just right now it is not taking the plane into consideration yet because the plane itself adds a little bit to what Rift has to advertise. So the schema elements are here, they're optional, but if you run a multi-plane implementation, you would have to advertise the stuff on the node tie, so other people can figure out which plane they are in, and what is the plane ID, and there are multiple planes, and then you have to take it into election. Yeah. Mm-hmm.
So you would also need to enforce at least one instance per plane, right?
Yeah, right. So the algorithm will take care of it, right? So it will basically, just like we have preference and then we have system ID ordering, we will basically, the same way we take the highest system ID, lowest system ID, second highest system ID, second lowest, we'll have the plane ID in front. The plane ID is basically nothing else but the highest system ID within a plane. And that's why everybody in the plane starts to advertise, those are all the guys in the plane, so okay, the guy with the highest system ID is actually the plane ID. And then the other guys who don't necessarily see all the guys in the plane know what is the plane ID, and having all the plane IDs, they can actually run a consistent election where the FRs or RRs will be basically spread across the planes, right? So first you take the plane into consideration, then you take a priority within the plane, and then you go the high ID, low ID. So if one crashes, you don't get immediately, like flip over. So you basically get for free a BDR behavior for, SPF. That was a lot of acronyms. I hope somebody could follow that.
I think we're down to the last one.
Yeah.
So Sandy, you have 40 minutes.
Hello, do you hear me?
Yes.
Yeah.
Okay, thank you. A lot of time, very fortunately. Hello, hi everyone. I'm Sandy Zhang from ZTE. This presentation is for supporting leaves without northbound neighbors connecting to a fat tree network using Rift. We have co-author 岳华那本虫. Next, please. Though the draft has been presented before, but let me explain it again in case somebody listen it the first time. In the example metro network, the spine leaf topology can be deployed to replace the traditional topology. Rift can be used as the dynamic routing protocol to build the network. The access network may connect to the core network by leaf nodes by ring or chain topology. For example, IBRAN network. Next, please. This figure is the leaf part of the network. We know in typical Rift protocol, every leaf node has northbound connection with spine node. In case a leaf node lost all the northbound connection, it can still access the network by east-west neighbor leaf node. But in this deployment, some leaf nodes never have northbound connection, even if their east-west neighbors haven't northbound connection also. Looks like they can access the network by the east-west connection, but according to the typical Rift protocol flooding and the SPF algorithm, the leaves cannot advertise their prefix north tie to the network, and the leaves cannot receive the prefix south tie from the default route true. For example, in this figure, there are 6 leaf nodes, but only L1, L2, and L3 have northbound connection with spine nodes. L4 and L6 can access the network by L1 and L3, but L5 cannot access the network because it and its neighbors haven't northbound connection. Next, please. In order to solve the problem, the key is let the leaf node without northbound connection receive the prefix sort tie from for default route from the east-west neighbors, and send the prefix north tie to reach to the leaf node which has northbound connection. This is a change for the flooding. The leaf node without northbound neighbors must transfer the prefix source tie received from an east-west neighbor to the other east-west neighbor, which also has no northbound connection. And the leaf node without northbound neighbors must transfer the prefix north tie received from an east-west neighbor, which has no northbound connection to the other east-west neighbor. Other flooding function and the SPF algorithm are not changed. So in this figure, L4 and L6 must transfer the prefix source tie received from L1 and L3 to L5 with increased metric, and L4 and L6 must transfer the prefix north tie received from L5 to L1 and L3 with increased metric. So L5 receives the prefix sort tie and find the way to access the network by L4 or L6. L1 and L3 receive the prefix north tie and pushes the tie to spine node. And the nodes in other side of the network can send the flow to L5, and L5 can send the flow to the other nodes in the network. A new link capability is defined and named as leaf transport. It can be set in lie and node tie. This capability won't affect the lie FSM. Next, please. This draft has been presented in IETF111 and has been discussed in the mailing list. In the update of version 01, according to the suggestion from last meeting, we added the description of external prefix north tie transfer. That is, the leaf node without northbound neighbors, which supports the leaf transfer capability, must transfer the external prefix north tie received from an east-west neighbor which has no northbound connection to the other east-west neighbor. So that's all. We are looking for more comments and suggestions. I'm not much sure if this extension will be considered in the new charter, but it's great if working group can consider about it. Thank you. Any comments?
Hey, Sandy, Tony P. Juniper. Right. Can we flip back to the topology picture, please? Right, this one. So first observation, I don't know whether I made it already last time. You kind of generate a corner case of a corner case and solve it, because if you don't force this topology, the L nodes to be leaves, then Rift automatically solves the problem as it stands today. Imagine that LO4, LO5, LO6 are not forced to leave, right? So the LO5 by ZTP will automatically end up a level below. So it will start to look like a sink below, right? So it's a very degenerate claw. LO4 is only single-homed, LO6 is only single-homed, and LO5 is dual-homed. But based on normal D4 route advertisement, the whole thing will work. So Rift will support the stuff today. Now, if you tell me that you're interested in the corner-corner case where you force all these nodes on being a leaf, then yes, what you're suggesting, I have to think about this new addition through, whether that can possibly loop, but what you're suggesting will work, right? Already the horizontal link support will basically give you. So I think the stuff that you're extending as the flooding is already in the spec. The only thing I would strongly object is, can you flip one forward with the procedures, please? All right, so you never flood on a southbound tie. So if you really want this prefix south tie transferring supported, nothing wrong with that, but basically what you have to say, you have to take the prefixes you received southbound and you have to regenerate your own southbound tie. Otherwise things won't work properly. If you start to propagate ties, southbound ties, multiple hops, you will end up in trouble. Plus it breaks the whole architecture completely. So one suggestion how you solve it implementation-wise is that you support a policy where you can take a prefix that you got from southbound and you redistribute it into inside. Basically you say, okay, whatever came from the north in the south tie, re-advertise it southbound. So it's basically a prefix redistribution within the protocol, which will work fine from experience. So two observations. First, you're solving a corner-corner case that you kind of call upon yourself if you force those things being leaves, which I don't see a reason for, but you may have one. And the second one is that you cannot reflood the southbound tie. You have to regenerate it because the originator has to be one level away. Okay? Otherwise, like I said, corner-corner case.
Okay. Let's see. Because we think if Rift want to be used in many deployment, maybe this corner case will occur. So we think that it may be a use case for Rift. But as you said, if we use the ZTP function of Rift, we can generate the level automatically. And so some leaves will not be leaves and it will be spine. That's a way to solve it, but we know that in some network, the leaves may be not stable. So in case there is some breaking or something other, there something other happened, maybe and the level will be broken and it will be generated again. So that's why we don't want to use ZTP for here. And in the other side, if we use the new link capability, it can be strictly configured in limited nodes, so it may avoid the wrong flooding of the tie. It can avoid the looping, but it's just analysis for now. Maybe in some cases it will still cause the loop, as you said.
No.
Yeah.
No. Because the flooding in multi-plane case on the rings, read the section on the flooding procedures, or rather the flooding scope when you have a ring at the top of the fabric. You try to introduce exactly the same flooding at the bottom of the fabric. That's what you're doing here. You are ringing the bottom of the fabric, just like we're ringing in multi-plane case, the top of the fabric. And the same flooding scopes will apply. That's why I told you stuff will work, but you cannot regenerate the south tie. So read this section, think through it. And you are not solving any looping problems. The only valid reason to do what you do here is to say that I do never want those leaves to be transits, but actually you're already violating it. The LO6 is a transit here, and think about the failure of link between LO1 and LO4.
Yeah.
LO5 will become transit anyway, otherwise you're black holing. So even the corner case, you think you're solving, you're not solving. If you just leave those things not being forced to be leaves, you achieve exactly the same behavior that you get with all the changes that you try to introduce additionally here. So, I mean, brutally speaking, I think this is largely superfluous. It could be done, right? At the top of the fabric, we had no choice. We had to ring those things and we had to get the flooding scopes. If you want to do that, yeah, okay, we just repeat the extensions for the top of the fabric rings. So you can basically read that and compare with what you try to extend, and you'll find that you're pretty much doing the same thing. But I really don't see the value. Could be done, but I don't see the use case that you ultimately are solving, unless you're willing to, for example, black hole LO4 if LO1, LO4 links dies, and then LO5 really behaves like a leaf and never forwards through it. It's never transit, but then you will black hole LO4. Then basically you don't have ring resiliency anymore. And if you have ring resiliency anymore, if you just leave Rift as it is, you will get it by itself. Okay.
Tony, just indeed. So if we keep it as is, we actually logically build 7-stage, right?
Correct.
So LO5 is going to have parent relationship or child relationship to 4 and 6. However, on breakage of L1 to L4, you'll have to re-elect and change.
Well, then you will have LO6, LO5, LO4 will
you'll
fall
have
beyond
L4
LO5.
into L5 and L5 into L6.
And that's how it will work, which is exactly what you can get out of a ring protection here, nothing more. And Rift will solve it for you by, yes, behaving counterintuitively because it will build a chain downwards. But the forwarding behavior, resiliency will be the same.
So I'm trying to understand the behavior. Now L4 is...
very, very bottom.
Yeah, so now L5 is very bottom, right?
At this point in time, the LO5 is very bottom, dual home.
Yeah, so when link between L1 and L4 breaks, you change the relationship, right?
Well, the ZTP will basically, the LO5 will look at the offers it got. It will got LO6 and LO4. LO4 will withdraw its offer. LO5 will say, I'm still good. I got from LO6, whatever level, I'm one below. The LO4, we realize it has no valid offers because the only valid offer for a level was from LO1. The offer is gone.
But there's no ZTP, there's convergence. Right?
Sorry?
There's no ZTP, there's convergence on breakage of the link.
No, but you also have the ZTP because they have to change levels.
Yeah.
Right? So the ZTP, it will all run at the same time, right? The LO4 will basically start to change its level under LO5. The best offer it has right now, which level it's at, is from LO1, right? So the problem is if you set all these things to leave, they're all at level 0. See what happens? So if links break, they
Yeah,
cannot
you
change
lose link
levels,
protection.
right? So you need all these special flooding scopes. Just like the top of fabric cannot become lower than top of fabric. That's why we need the ring flooding. So now the zero becomes like top of fabric. You have to do all the ring flooding, which if we take the top flooding rules, scopes, which is kind of what they suggest here as extension, it will work, but it's just overly complicated because normal Rift, by changing the levels and ordering those guys, will provide you all the correct forwarding behaviors and all the link breakages here. Yeah. So that's kind of my point. If you really want to force those guys all on belief and zero, okay, then you need this. But why you do that? The only reason would be you don't want it to ever be a transit for traffic. But then you cannot protect LO1, LO4 failure because LO4 has only LO5 as transit. If LO5 refuses to be transit, you have no ring protection anymore, right? So I'm like, yeah, we can do that, but I simply do not understand why it would be necessary unless you really want to prevent those guys being transit, which breaks the ring protection. So that's my input here.
Sandy, what do you say?
Yes, I think that DTP is not a good choice for this situation. So I think that we should not use DTP here, but as Tony said, configured prefix redistribution may be considered. So I'm not think much more about it, but I will. So I think that if we think that the new link capability will break the algorithm of the Rift fundamentation, so we may not use it, but we can find another way to solve it. Though it's a corner case, but in my opinion or in our customer, they think it may be a deployment for it. So we think this maybe it's a corner case, but it still needed to be solved. But we can try another way, like Tony said, the prefix redistribution.
Or send it first, just switch off leaf flags on L1, 2, 3, 4, 5, 6, break links and see how it behaves. And you will see that you get the ring protection. You don't have to do anything.
Yeah.
Just switch off the leaf flags and you'll see the topology is supported.
Yeah, but during the level changing, the convergency time may be considered about it.
That is a pure implementation consideration. Okay, so right, if you start to become very concerned about that, and you say, I do not want to run the election of the level, and you think that will save you convergence. Yes, it will, because you just have to disable the next hop. If you really need it, yes. So I give you that, right? I mean, frankly, the ZTP runs within well-implemented finite state machines. My experience runs within milliseconds. So at most tens of milliseconds, right? To get all the accelerated hellos and ZTP, because we put the ZTP on the hellos and the hellos get accelerated on failures. My experience is it's, I can run on my implementation well under 50 milli, the whole thing. Now, if you're concerned about that and you just want a fast path to disable, so let's say LO1 to LO4 fails, and you just want to kill from LO4 the next stop. But see, the problem is, see, on the rings, you have to follow the shortest path because you will loop. So go look how the ring flooding on top works and how the computation is done. Because you cannot install now in the forwarding table something on LO4. So let's assume it's all default, right? So you cannot install in LO4 a default entry that has next stop LO1 and LO5, because that may lead to looping behaviors, okay? Because you are not on a claw. The whole, you're not in value free routing anymore. the whole Rift trick of being able to take any path is because it's completely valley-free. This is not valley-free, this is flat. You can go up and down. So if you basically naively install LO4 default route with LO1 and LO5 next hop, disregarding the distance here, if people start to build weird stuff and shortcut it, okay, you will start to loop, which means that you're forced anyway in such a scenario to install default on LO4 that has only next hop LO1, which means if the link fails, you still need to download into LO4 with the LO5 next hop. Okay, so you won't be able to accelerate convergence in the generic case. On this little thingy that you show here, depending how you treat the O2, O5, O3 links, if you follow Rift today, you will not loop. With your extensions, I cannot tell. But in the generic case, if you start to introduce this flag, you can only install shortest path because you're not in valley-free routing anymore. You're not guaranteeing that. Okay, so I don't think you can accelerate convergence either, practically speaking, depending on a million things, right? You can pre-compute stuff and accelerate, but practically speaking, I don't think you'll be gaining much. Okay, so that's my input to the whole thing.
So Sandy, so I'm completely with Tony here. Looking at implementation, you cannot use fast rehash because no endpoint in the network is equidistant. So you cannot have array of next hops. You would have to compute something like loop-free alternative, which Rift not suitable for, where L1 would be primary and L5 backup to switching hardware. Otherwise, you still need to invalidate next hop in RIPs and re-download the routes, which kind of defeats the point.
Yes.
So you are still talking about tens of milliseconds at least.
Yes, I think from our experience on the IDPX protocol, we think that the protocol convergence time will larger than the backup table convergence. So we think about the solution. But it's great if the ZTP's changing will still consume so little time. So it's great. But we have not tested on it. We think we can do more work about it.
No, so that's cool.
Yeah.
Sandy, so I like that, but why don't you, implement this? I mean, that's not a massive change. I advise you to look at the ring flooding on top. So you verify what you're doing here because you're changing flooding scopes, which is cool, but it's basically the same problem. So you can implement a variant of it and then run Rift just doing the election in your case and run this and see what is the difference. I mean, you don't have to bring absolute numbers, but show that in our implementation we see 3x improvement and then we chat. But I think you'll be a little bit disappointed. And like I said, don't forget, unless you compute loop-free alternatives, like Jeff said, you really go into IGP loop-free alternatives. That's literally where you're going into. You cannot just naively install the LO1, LO5 next hop. So you have somehow either extend the whole solution by LFA. That's a heavy thing. And don't forget, because you're flooding southbound, you will not see the topology. So I don't think you can even compute LFA, okay?
You cannot in this topology.
You don't have the full topology. LFA is very, very reliant on the fact that you see full topology. So see what happens if you switch Rift and just let it do the ZTP and rebuild adjacency reload, and what you can get out of your extension if you lose the stuff and you just redistribute the prefixes and you recompute the prefix to the neighbor without losing adjacency. I will see how much you can get out of it, because right now it's bit hand wavy. I get your point, but I would be far more interested in the solution if you show me very significant, half order of magnitude gain in terms of failover protection. Okay.
I can only imagine static configuration of backup paths, but again, it's kind of very implementation specific.
Yeah. So I think let's be don't consider the solution. We just consider the situation. Is this situation or the deployment need to be considered, or this situation makes sense? How do you think about it? Despite of the solution.
Oh, I think that what you're showing here is deployment is stuff that I've already seen and people were talking to me. The ring deployment at the bottom is absolutely valid, no discussion. So the topology you're showing is reality. And I saw the stuff like this, I saw it double ringed, I saw already all this stuff. Yeah, the topology is absolutely of value, no discussion. Yeah.
Okay. We can consider about it, and maybe this will not be an extension for Rift, or we just list some solution and compare it, and we can do some conclusion about the Rift fast convergency or other some things. Do you think so?
So if we're really looking for work, okay, and relevant work, these rings are mostly lambdas from what I've seen, okay? And these lambdas are building either at the bottom or the top of the fabric. And they are counter rotating. And actually, when you cut the link, you only lose half the lambdas. So it's a very, very weird thing. And we have an extension for Rift that deals with the stuff. If we want to go into this direction on the charter, we can have a chat what problems that poses and what kind of solution that needs. And we could start to work on the stuff. But let me be honest, the customers that we had that got extremely interested, wanted the stuff built, basically pulled out. So we never built the stuff at the end. But the problem is valid when you start to deal with RODMs and counter-rotating RODMs doing special reuse on lambdas. Probably too cryptic, you know. But yes, the ring topologies they present unique problems. Yes, that you can do funky stuff. Not in this case, but at the top especially.
Tony, when you say we, you mean your employer?
The guys who settle my check, every month. Very graciously.
So, but is it something that you would be willing to bring into IETF?
Yeah, we could. I think we actually have IPR on that stuff. We worked all the stuff out. We've kind of had it conceptually all shown, and then basically, the guy who was supposed to sign a big check for the stuff didn't come through with the whole thing. But if we want to go into this direction in IETF, and you guys want to put in a charter work on, yeah, absolutely. And then I explained the problem, and it's very, very weird but extremely valid problem for the optical guys. Okay. Because now we talk about the ring stuff. So the ring shows up. In this situation, it's kind of simple. Just let the Rift run. It will work. At the top of the fabric with the losing half the lambdas is actually far more interesting stuff.
So I think if there's demand, we will be happily willing to entertain Rift and rings work.
Right. I mean, there is no demand. I mean, I don't have the customer signing the very big check. No, that's why the work is dormant. Yeah.
I mean, since Sandy is working, and there's demand, right? Hopefully.
Yeah, but it's a different case. Like I say, it's mostly top of the fabric when lots of fabrics are being hooked up on a big counter-rotating RODM ring. That is the real stuff, because there you really need the lambdas, right? And the RODM behavior starts to matter.
No, but in Access case, it's actually at the bottom, right? And it's
but then you just let Rift run as it is. You don't need anything.
What happens if your ring is larger?
You just more and more levels. That's why I have so many levels in Rift. And the ZTP is so fast, it really doesn't matter. See, the whole ZTP has been optimized. So when you, the whole ZTP is built asymmetric for the failure case, right? So it comes up, it's slower. When it goes down, it's really, really fast.
So imagine there's a node between 4 and 5. So when it initiates, one is upstream and another one is parallel, is horizontal, right?
Yeah, correct. So you either have to allow horizontal links, or otherwise you'll be single homed. Yes.
Yeah.
Correct. Yeah.
So I think it would be
So that
very
is
good if you.
already a more interesting case we could talk about, yes.
Yeah, I mean, this one is easy because of odd number of nodes, right?
Correct.
So you've got here a clear structure.
Yeah, yeah. I mean, it's at least that, I mean, even if we don't do those extensions, it already merits a draft just to talk people through, okay, how do you deploy these rings and what are the operational considerations, right? So you want an implementation, for example, with horizontal links, yes, for that reason. And then it's absolutely valid operational consideration. What will be the convergence times, right? Because imagine this ring gets really big, right? And all of a sudden the ZTP has to converge 10 levels. Yeah, it's an operational consideration, no? Because there you will have you lose all the adjacencies. FSM today, the moment you kind of go, oh, I have to change the level, drops adjacencies because it's, you know, the offers are not valid anymore, right? On a level change, we're dropping adjacencies. So if you go all the way to the extreme, you could actually, in the leaf case, change the FSM, right? Like do not drop, keep on forwarding and so on. Your leaf life will be good. You readjust. So those are efficiency improvements for ring deployments, but yeah, those are valid consideration, no discussion, you know.
Can we start some exchange of emails on the list? I think it's a valid problem and actually interesting solution. We know that convergence on rings is horrible unless you use tunneling or some label stuff. It's very painful. So if we can solve it, and given how fast Rift is, you know, it could be a good solution.
Okay, so I mean, I don't have customers pushing me right now with huge rings, right? So yes, in the interesting work topic, it will be like kind of forward-looking, and if Sandy, you know, that really pesters them, okay, I would still encourage first an operational draft and then seeing what numbers we have on the convergence, then we start to consider like hacking more into the protocol, which works fine without these extensions right now. Okay.
Sandy, let's start with your describing your requirements. Again, half of Europe is this kind of rings, right? They all run like RCPT in both directions, and it's really horrible.
Yeah. Yeah. Okay, so up to the chairs to drive discussion. More than happy to participate. Okay. Good.
Okay, we will decide.
Tony, it's great if you can provide some test number or analysis about the converging time about the ZTP, because we can test of dozens of devices in the ring, so we can see the convergence time. What's the number of it? Could you please do some test on it? We can do it also. Yeah.
Sandy, I don't have cycles for that. You may get someone like Jordan who may have to burn some cycles and want to play. I simply don't have cycles to give you those numbers. I don't have customers pushing me on the stuff. I have convergence number, internal numbers, obviously, but I cannot disclose those. And for that case, we could do something and show it, but I don't have the cycles for it. It will be up on you.
Okay. Okay. I understand. We think that it's.
I mean, what I can tell you is that.
Yeah.
So the loss of adjacency is a very complex thing because it depends whether you lost the light or whether the BFD went down or whether the hellos timed out, right? So it's an extremely different behavior. So you first have to say what we talk about. When we plug in the optics, the adjacency is fully up within somewhere between 20 to 100 millisec. But that does not mean anything because you have to flood shit out first. Sorry for my French, right? So until you flood that stuff out, you don't have anything anyway. So the adjacency bring up time is actually not even that interesting. What is far more important, do you have the database, all right? And then we start to talk about how fast can you flood? And the discussion becomes incredibly complicated very fast because it depends on how big is your fan out, how much CPU do you have, blah, 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 right? How big is the database? The space is n-dimensional. And then your best way to actually start to quantify that, and the Katara guys did the paper, right? And they've shown you roughly, it becomes far more interesting how far you flood before the whole thing is converged, rather than how fast can you flood across a single link. Because what you see then with BGP on the failures that it goes through the whole fabric back and forth, and that makes the total convergence much slower than something that only floods one hop, right, on the prevalent failure. But the Katara guys did the work. So here, flipping on BGP and then failing a link and starting to quantify convergence, you know, the Katara guys may get very interested in this stuff, because they have the full framework for it. For them to bring the stuff and play with the stuff, they have our implementation, you know, they have access to it. So they can actually converge, you know, compare. Python is of course slowish, right? But they can play with the Python, they can play with our stuff, they can play it with ISI's, BGP, just basically doing just like this, right? So Katara guys, poke them. They love this kind of work.
Sandy, you know who Tony means, right? We had a presentation in 114 on routing. Italians. So reach out. I think they'll be more than happy for use case, and their software is really good.
I think Tommaso and those guys will be more than happy. You know, there's a bunch of PhDs going on, and they have a superb framework that can very quickly bring the stuff up. Okay. And frankly, I'm doing most of my, like, you know, hammering the stuff now, you know, around containers in their framework, not even using, you know, like large amount of machines or anything like that. So that will be a great idea. Let's involve Tommaso. Let's start to talk through this issue. Quantify the ring behavior versus BGP or whatever, normal Rift with these extensions. I think that will be a very productive thing to do, and quantify not in terms of like 5 milliseconds versus 7 milliseconds. It's like, okay, what is the total load message-wise and processing-wise, and, you know, failure scope that you put on the network on a failure in each of those scenarios, because this is then what tends to behave better, right? We will start to talk about these implementations a little bit faster, CPU and so on will never finish, because it's just basically watching a lava lamp. But the way they pull the metrics are very objective. You know, they basically discount a lot of these variables which are very hard to quantify. Okay, long discussion, very productive. Thanks.
So we are thinking of rechartering done by Yokohama, potentially. So let's start this discussion after this IETF and see how we converge. We just discussed with Jeffrey, will be more than willing to include rings in a new charter.
Thank you. Thank you, Jeff. Thank you, Tony. Very useful suggestion. Thank you all.
Very good job, Sandy and Tony. You only spared us 2 minutes. We're done here.
Yeah, thanks everyone, and we hope to see you at IETF116.
Yeah, and big shout out to Jordan. Thanks for picking up all the work, man. Tons of stuff, SVG and the document shepherding and so on. Thank you, man.
Yeah, thanks, Jordan. We received so many compliments for PDFs. It's just, you know, great work.
No worries. Appreciate it. Thanks for the kind words.
We'll make you chief PDF editor. Traveling? Are you coming to California at some point in time? You have like days and some stuff, right?
We don't have, so I was hoping to come to California last week, but the customer got canceled, and even had a meeting scheduled with our CTO. I couldn't go. Internal meeting, no travel.
Anyway, otherwise we'll do it over again.
Yeah.
Cool, thanks. So we need to
I'd rather